Hello, Physics Parallel Universe Part 2. So, we were considering the wave function of a quantum object. So, its probability is the square of amplitude. So, now we considered the Schrodinger cat experiment. So, in a box, there is a radioactive source plus a cat which is alive. So, in the radioactive, there are two possibilities: atom can decay or atom cannot decay. So atom, if they decay and detector detects the uh, radioactive activity and it releases the poison. When it releases the poison, the cat is dead. When cat dies, this is the one possibility. Another one is atom does not decay. Detector does not detect any radiation or is not activated. So there's no release of the poison and the cat remain alive. So there are two possibilities stem from the radioactive source. So the state of the cat, alive or dead, is directly linked to the state of the atoms and it's their decay activities. So the cat with atoms are entangled to each other. So quantum mechanics, the state of atom does not have a either alone decayed, but it has also not decayed. So the two states, decayed and not decayed, are possible. So the state of the quantum state of the atom is the superposition of some possibility of decay and some possibility of not decay. So wave function will be superposition of these two states. When no measurements are made, so atom and the cat and detector, there are three things altogether in the box. So the superposition state of the atoms, decays or not decays, are entangled with the detector as well. So instead of atom and cat, we have another thing which is the atom and detector uh, linked with this one, because so detector is a human and human is the composition of atoms. So superposition of the state of atoms, decayed and not decayed, is also linked to the cat and also linked to the detector. So state of atom entangled to the detector is observing or not observing. Observing or not. So these three things are now linked: atoms, cat, and detector. After some time, the wave function of the everything inside the box is in superposition state. So atom decayed, not decayed, poison not released, cat alive. This is one. Atom decayed, poison released, cat dead. This is another one. So the both state of the cat dead and cat alive at the same time. So this is also the possibility. So when we open the box, the wave function collapse. Cat actually either in two states, alive or dead. So essentially three state components of the Schrodinger wave equation exist. In superposition of the quantum object at two different states, two different places at the same time, and they are entangled with the two electrons from the atom, which are fired toward each other. If it is like this one, two electrons are fired to each other, so then what will happen? So they come together and then they will move with as a one one wave function. So the essential component of the Schrodinger wave equation are the three: superposition, entanglement, and measurement. Superposition of the state of the atom, entanglement with the cat, and measurement with the detector. So if there are two, so the quantum object at the two states simultaneously, like a double slit experiment, if electrons, so electrons are here, and if they are coming toward from the two slits, and if they interfere, so that means electron is going from this slit and also in this slit. So this is that's why there's a interference pattern. If the single electron is forced to enter into two states, one electron is going from this one, and it is not possible it can go from this slit as well. So single electron forced to enter in two states at the same time. So this is superposition of the states. So electron is spread out as a wave function. So that means electron is not a particle, but it is a wave. It is going through slit 1 and also slit 2. So now the entanglement scattered off from each other, uh, how their trajectory are given by the spread out of the wave function. So wave function give us the probability. As we measure the momentum of the electron, we immediately know that the momentum of the other electron if they are entangled. So there are two electrons, which is atom decayed, and there are electrons are emitted. So should be another electron which are linked to each other. This is a pair. So that pair have a properties. So if this is a plus going as a momentum on this direction, positive, and this will have a negative direction because initially this was a zero. So according to the conservation laws, so we immediately know from the momentum of each other from the conservation laws, starting from zero, that if it is positive, that will be negative. So the entanglement is based on the conservation of momentum laws. If we know one, we will guess about the second one. So before the activity of the atom, momentum of each electron before the system uh, involved, the momentum of each electron is in superposition of the states. So if measuring one collapses the wave function of the second one. So this is true if the electrons are in a light year apart as well. So if we measure the one electron, these are the two electrons which are coupled, so entangled. So if it is this one electron and this one is a far away, so if we measure this one and then other one will be on opposite direction, no matter how much distance is in between two of them. So before and afterward, before the decay is a zero, and afterward it is in a pair, they are entangled. These electrons are entangled. After the interaction, electrons do not have a separate individual wave function at all. They now have a single wave function as the and the space is a whole universe.